So, good morning, dear students. Myself, Dr. Hari Priya, working as Associate Professor in Chemistry, Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. In today's session, we are going to discuss about wet theory of corrosion. What is the mechanism that we have to adopt when a corrosion reaction takes place due to electrochemical attack? So, in this, anode reaction will be the same, common, but cathode reaction proceeds in two different ways, that is evolution of hydrogen gas type, and the second one is absorption of oxygen type. So, after that, we will go for what are the differences between dry and wet theories of corrosion. So, let us start with introductory part of wet theory of corrosion. So, for this type of corrosion reaction to study well, there are some satisfactory conditions for mechanism adoption. So, let us see one by one. First point is, we should be able to identify anode and cathode areas. That is the first point for applying this type of mechanism for corrosion reaction. First point is, we should be able to identify anode and cathode areas. So, after that, there should be a medium presence. That means these anode and cathode areas are in contact towards each other with the help of any medium, or we can say conducting liquid or conducting medium, or simply we will call it as electrolyte. That is environment. After that, always at anode we know that oxidation will take place, and always at cathode reduction will take place. This is the third satisfactory condition, it is to be satisfied. And coming to the fourth one, because of all these things, flow of electrons will take place from anode to cathode. As flow of electrons is possible, then current will pass from anode to cathode. That means there is a chance for formation of galvanic or voltaic cell on the surface of the metal. So, these are the four different points that are to be satisfied for applying this type of mechanism for corrosion reaction to take place. What is the first one? Identifying anode and cathode areas. Second one is identifying conducting liquid or medium. Third one is, and always at anode oxidation takes place. That means metal which is placed in anode will involve in corrosion reaction, and at cathode reduction will take place. And the next point is formation of galvanic or voltaic cell on the surface of the metal. So, after identifying all these points, that means a redox system it is identified. And then coming to the mechanism part, what will happen is, as I told you, anode reaction it is common. That means metals will have a tendency to lose their electrons by involving in oxidation and converts into their corresponding metal ions. Say for example, M is a general metal. By losing n number of electrons, it is able to convert into Mn plus ions. So, these metal ions along with the electrons, they try to move towards cathode. So, this cathode reaction will take place in two different ways. First one is evolution of hydrogen gas. This is possible if the medium is an example for acidic environment. And second approach is absorption of oxygen, that is due to medium is an example for aqueous neutral solution. So, let us go with the first approach of cathode reaction. So, in this mechanism part, anode reaction it is common. That means anode by losing electrons and involving in oxidation will convert into corresponding metal ions. So, after that, cathode reaction proceeds in two different ways. One is due to evolution of hydrogen gas, or second one is due to absorption of oxygen. So, let us start with first type. So, this is possible if the medium is an example for acidic environment. So, this type of cathode reaction takes place if the medium is an example for acidic environment. So, let us say I have considered the example of iron metal. As I told you, by involving in oxidation, that is anode reaction, it is able to lose 2 electrons, thereby converting into corresponding ferrous ions, that is Fe plus 2. So, this is the metal block of iron, and by involving in oxidation, that is by losing 2 electrons, it is able to convert into ferrous ions, and this is acting like a anode, which is acting like anode. So, this area it is acting like anode. So, after that, what will happen? Medium presence should be there, because we are telling that we have to identify the formation of galvanic cell or voltaic cell on the surface of the metal. So, we have identified anode and cathode, and then medium presence should be there for the complete reaction to take place. So, here, as I told you, medium is an example for acidic environment. If medium is an example for acidic environment, then it is able to release H plus ions into the solution. So, that released H plus ions are able to involve in reduction by gaining the electrons that were lost by the iron metal. So as a result, redox system gets completed. So if you notice the net cell reaction, iron it is combining with 2H plus ions, thereby releasing hydrogen gas along with the ferrous ions into the solution. So if the medium is an example for acidic environment, then cathode reaction proceeds via evolution of hydrogen gas. For examples for this type of cathode reaction will include metals which were placed above hydrogen in the electrochemical series. So generally they will show this kind of tendency that to get dissolved in acidic solutions, thereby releasing hydrogen gas. So if you notice, in the case of cathode reaction that is taking place due to evolution of hydrogen gas, anode area is large and cathode area is small. So in this case, anode area is large and cathode area is small. Coming to the second type of approach, that means cathode reaction takes place due to absorption of oxygen. So this is possible if the medium is an example for aqueous neutral solution. Aqueous neutral solution. So if such kind of medium presence is there, then cathode reaction proceeds via absorption of oxygen. So for this one, I am going to consider the block of iron which is having a small crack or pore on the surface of the metal. So this is the small pore or crack what we are going to imagine. So, and then as I told you, it is having neutral aqueous medium. Aqueous in the sense it will have water as solvent. So these droplets are nothing but of aqueous neutral solution. These are the solution molecules that were present on the surface of the metal. So as they penetrate, that aqueous or we can say water droplets penetrate into this hole along with the oxygen, atmospheric oxygen. What will happen? Let us see the mechanism part. So this small part of pore or crack will act like anode. So this anode, what it is doing? Anode is nothing but the iron. By involving in oxidation, that is losing electrons, it is converting into corresponding ferrous ions. So these ferrous ions will move in upward direction along with the electrons. So these will move in upward direction. So along this pore or we can say crack, availability of atmospheric oxygen is there along with the aqueous solution I mentioned as electrolyte. That means it will have water molecules in solution. So oxygen combines with water molecule in the presence of electrons. That means involving in reduction. If you notice the reaction, oxygen by involving in reduction with the help of water molecules, it is able to release OH minus ions, hydroxyl ions into the crack or pore. These hydroxyl ions will combine with ferrous ions, thereby converting into ferrous hydroxide, Fe2 plus, combining with 2OH minus ion, able to produce ferrous hydroxide. Ferrous hydroxide will be the result. So this is what we call it as starting of rusting of iron. So let us see the reactions part. So as I told you, iron what it is doing, anode reaction, if you notice the anode reaction by involving in oxidation, it is able to convert into corresponding ferrous ions. So meanwhile, because of absorption of oxygen at cathode, in the presence of aqueous electrolyte and electrons involving in reduction, it is able to release OH minus ions. Oxygen is able to release OH minus ions at cathode. So these OH minus ions along with the Fe plus 2 ions combine to form ferrous hydroxide. So this is what we call it as initial stage of corrosion reaction on the surface of the iron metal. So if the availability of oxygen is plenty, then this ferrous hydroxide will involve in further oxidation to ferric hydroxide. FeOH taken twice in the presence of atmospheric oxygen and aqueous electrolytic solution, it is able to convert into ferric hydroxide, that is FeOH taken thrice. So this is what we call it as rusting of iron, which is reddish brown in color, Fe2O3, 3H2O. This is hydrated form. Further, it will convert into anhydrous form of rusting of iron if availability of electrolyte it is not there. So this product is what we call as yellow rust. Actually, this will correspond to Fe2O3, 3H2O. If this water content it is removed, it becomes anhydrous form, that is black colored one, which is known as magnetate, Fe3O4. So this is what we have. identified in the mechanism of cathode reaction that is proceeding if the medium is an example for neutral aqueous solution, that is due to absorbing atmospheric oxygen. So if you notice the differences, we have proposed two different theories. So what are the major differences between those theories for explaining corrosion reaction? Why two theories were introduced? So let us see. So after knowing the differences between these theories, we will get a clear idea why we have to implement two different theories for explaining the mechanism of corrosion reaction. So first one, it is dry theory, and second one is wet theory. So it is purely occurring in dry conditions. That means there is no question of medium in the place of dry theory. Whereas for wet theory to take place, that means it will have the presence of electrolyte. That is, medium presence is must and should in the case of wet theory mechanism, but that is not there in the case of dry theory. So it is purely due to attack of oxygen or other atmospheric gases. So this is purely due to electrochemical attack. And this type of corrosion reaction, it is uniform. If you notice this one, it is non-uniform because in this anode area is large. Anode area is large. Here anode area is small. It will have a small anode area. So corrosion products, they accumulate at the site of attack. So where chemical atmospheric chemicals like oxygen and other gases are going to attack on the surface of the metal, there itself formation of corrosion product will take place. Whereas in the case of this wet theory, formation of corrosion product takes place somewhere between areas of anode and cathode. So it is a slow process and this is very rapid, or we can say fast process. So in today's session, so far we have completed learning about or discussing about mechanism of wet theory of corrosion. So in which anode reaction it is common, whereas coming to cathode reaction, it is of two different ways. One is due to the evolution of hydrogen gas, second one is due to the absorption of oxygen gas. So in the coming session, we are going to learn about what are the various factors that are responsible for influencing rate of corrosion reaction. So that's all for today's class. Have a nice day.